Alright, so following on from the previous video where we looked at the compound angle formula, we can actually learn about something called the double angle formula. And the double angle formula is when we have 2a, so for example sine 2a, cos 2a and tan 2a. And they are actually derived from the compound angle formulas. So you can see here what sine 2a is equal to, is 2 sine a cos a. Cos 2a is equal to, well, there's three different forms of cos 2a, so there's a cos squared minus sine squared. There's just a form in terms of sine, so it's 1 minus 2 sine squared, or 2 cos squared minus 1. And each of these have their own uses. So in certain questions, you might need a sine squared form, or in certain questions, you might need cos squared. So it just depends upon the exam or the question type. And finally, the tan 2a one, it's 2 tan a over 1 minus tan squared a. Once again, like the compound angle formulas, you just need to be very, very familiar with these and just find it very easy to use, okay? So as I said, they are actually derived from the compound angle formula. So just a quick derivation, or just showing how they are actually derived. So for sine 2a, I can rewrite that as sine a plus a. This way now I can expand it using the compound angle formula, where a is a and b is a as well. So this I can say is sine a cos a plus cos a sine a, which is the same thing as, they're the same thing, right? So it's 2 sine a cos a, like this. It's very simple, right? And the rest is actually the same. They just replace the cos 2a with cos a plus a, tan 2a with a plus a, and just simplify it a bit. The way we go from here to here is, well, we know that identity 1 plus, well, sine squared plus cos squared is 1, right? It's just using this to replace it or substitute it in, so we're just left with just sine squared or with just cos squared. So with this, we can actually do more questions, do more solving, do more proofs. So let's take a look at this question here. So in this case, it says cos 2x over cos x plus sine x is equal to cos x minus sine x. So cos 2x over cos x plus sine x. So we need to go about expanding it. So cos 2x, we can expand by saying it's cos squared minus sine squared x over cos x plus sine x, which I can now factorize. So we have cos x plus sine x times cos x minus sine x over cos x plus sine x, which will cancel out, leaving us with cos x minus sine x, which is the right-hand side. Okay, it's just a matter of simply expanding the double angle formula. Maybe we can look at the second one here. So half cos 2x minus sine 2x is equal to cos squared minus cos x sine x minus a half. So half cos 2x minus sine 2x. Once again, this is 2x, we can expand it, right? So we can say it's half cos squared x minus sine squared x minus 2 sine x cos x. We should look at what they want us to make, right? So as you can see, there's no sine x term on its own, right? So ideally, we just want to change it to cos squared only. So I can say it's half 2 cos squared x minus 1 minus 2 sine x cos x, and they divide everything by 2, and this is what they wanted in the right-hand side. Okay, so it's fairly simple stuff. Right. Part B, hence or otherwise, show that the equation cos theta in brackets cos 2 theta over cos theta plus sine theta is a half. So cos theta in brackets cos 2 theta over cos theta plus sine theta is a half. Whenever they say the word hence or otherwise, it's like a hint saying you should probably use what we just answered in the questions before. And so what you can see is, well, this term here, the bracket here, it's very similar, or actually it's in fact the same thing as the left-hand side of this first part here. It's just theta is x. So I can replace this left-hand side with the right-hand side, cos x minus sine x. So I can say it's cos theta, and then we have cos theta minus sine theta is equal to a half. I can expand this and bring minus a half to the left-hand side. And what you should realize is now this part here is actually equal to the right-hand side of the second portion of the question before. So I can replace it now with half cos 2x minus sine x. So half cos 2 theta minus sine 2 theta. And if I rearrange, I will get that sine 2 theta is equal to cos 2 theta, which they wanted in the question. So hence or otherwise, just a hint that you should be using the previous answers. And then finally, C is solved for between 0 and 2 pi, this here. So this part is relatively, we've learned to do this part before, so it's just a matter of just changing to tan and finding the angles using the class diagram. Okay, so let's just try one more thing. So let's say by writing 3 theta sine, or 2 theta plus theta, show that sine 3 theta is equal to this. Well, so sine 3 theta, they said that we write that as sine 2 theta plus theta. The reason why they asked us to do this is because we should be using now the compound angle formula, right? Because it's something plus something. So this will be now sine 2 theta cos theta plus cos 2 theta sine theta, like this. Okay. Now, if you look at the left right-hand side, there's no 2 theta, so there's only terms of theta, so we should expand the sine 2 theta and the cos 2 theta. So this sine 2 theta is 2 sine theta cos theta times cos theta plus. Now just to choose which one we're going to expand cos 2 theta with. Well, if you see there's no cos term, so we should probably expand it in the sine term. So that's going to be the 1 minus 2 sine squared theta times sine theta, like so. We can now expand, so 2 sine theta cos squared theta plus sine theta minus 2 sine cubed theta. Once again, we don't want this cos squared term, so we want to change it to sine squared. We can change it by saying it's equal to 1 minus sine squared, like this, and if we expand this, then we should probably get the equality or what they wanted on the right hand side, like so. So it's just a matter of using the double angle formula and the compound angle formula. That's why it's very, very important that you're very familiar with each one and you know when to use each one as well. Right, part 2, hence or otherwise for between 0 and pi over 3, solve this. So once again, they are asking us, they're saying hence or otherwise, which suggests that we should probably be using the answer we got before. And so what we can do now is, if I bring these two terms to the right hand side, I get 6 sine theta minus 8 sine cubed theta. And this looks very familiar, right? Because if you look here, it's actually very similar to this, but we just have to multiply by 2 to get the right hand side. So if I divide everything by 2, I actually get what we got previously in the previous question, which means that this is equal to, was originally equal to sine 3 theta, so I can say now half is equal to sine 3 theta and then work out my theta values accordingly. I'm not going to work it out because this is part we've done a lot of these questions beforehand, but the fact that we can manipulate it using the compound angle formula is an important part of this video. So maybe just go back or go through some questions in which mixes in some compound angle and some double angle formulas and just give them a go. And as I said, the best thing is just to be exposed to for a wide variety of questions.